again, the PID and the child gets sent to 0, and the parent non-zero. Then we've got the if PID does not equal 0. So in this parent, this sig child gets now paired with handler 2. So this association for the parent process is no longer there. We can only associate one signal with one handler function. So sig child is now paired with handler 2. In the child process, sig child is still paired with handler though. Any questions about that? Karen? Okay. Alright, so then we have an int I getting set. That doesn't really affect us right now. And then we've got if not fork. So we fork again. We fork all of the processes right now, since all of them are running through this exact same code. So we've got the parent. And then we know that return value of fork, we're looking, in order to enter that if statement, we're looking for any value of fork that is 0. So all the child processes are going to enter that if statement, and they're going to exit. So the child process here is going to exit, and here is going to exit. Yeah.
So the main branch of the child where PID is 0, is the PID set to the PID of the parent, which is 0 in this case?
So no, right now the return value for this guy is the PID of its child process, which is not 0.
Okay.
So that's why it doesn't enter the if statement, even though it's still kind of technically a child process. Any questions about this? Yeah.
So, if not fork, that makes every single process case child.
Yeah, so anytime you see a fork function called, that creates a child process.
But the not fork.
The not fork is looking for the return value of fork, and then that's like if condition. So that return value of fork, you take the not of it, and that's your if condition.
Okay, so since the child which is 0, none of that two bubbles.
Yeah.
Got it.
So any children that get created right at that fork call have a return value of 0 for fork, so they're the ones that get killed. Yeah.
So the whole point about if statement, so that whole for each child
Exactly, yeah. So in that chunk of code, any child that we just create, we kill immediately. The one thing we haven't talked about that, so when those two children get killed, remember whenever you kill a child process, it sends a sig child signal. So right now we've got sig child happening. Alright. So we know that the sig childs were paired with handlers, yeah?
So another way to say that would be anytime you see an exit, that sends a sig child.
Yeah. So, no, actually that's not correct. So if a parent exits, that will not result in a sig child. It's only if a child process exits will it result in a sig child.
the sig child doesn't get sent to that parent, but that's the sig child.
Yes, the sig child signal gets sent only to the parent of this one. So this sig child signal here gets sent to this parent, not to this parent. So right now, this sig child signal was connected to handler 2, and this sig child signal was connected just to handler 1. We'll come back to that later when they're counting up how many count 1 and 2s we've got. We're just gonna keep running through that, but for now we'll just say that we've got 2 sig childs there. And then we've got while wait null does not equal 1. So that basically waits for any child to get, all the children to get killed. So at that point we know that this main parent, very main parent, is going to wait for all of its children and grandchildren to get, all of its children to get killed, who are in turn going to wait for their children to get killed. So we know that eventually this child is also going to get killed off before parent returns. start running through, yeah.
So the weight from a while, how do you determine like his child is
So that weight statement is going to, it basically just tells any current process running to wait for all of its children to get killed. Once they are, then it can move out of that weight and hit those printf statements. Alright. So we'll actually answer question A now. So how many sig child signals get generated as this program executes? And we can go through and count how many sig child signals we've got, and we've got 1, 2, 3. Which should seem correct because we created 3 children from parent process. Yeah.
so count one is two.
We're gonna go through that. So count 1 and 2 are gonna be different for what kind of process you're in. So we're gonna go over that right now. Okay. So now for B, for the child process generated with the initial fork. So right now we're looking at this process right here. So this was the initial fork. We're looking at this child right here. What are the values of count 1 and count 2 variables printed at the very end of the main function? So here, starting from right here, you can see that it receives 1 sig child signal. Okay, actually let's start here. So right here, we know that counts 0 and 1 should be 0 for both of those because there is 0 for its parent, so it inherited a 0, 0 count. Alright. Now we know right here it receives a sig child from its child. And we know that that sig child is paired with handler, which increments, should increment count 1 by 1. That general handler function. So we know that that sig child will increment count 1 by 1. So we've got right now count 1 equals 1 and count 2 equals 0. We don't have any other signals coming from any of its children, so that's where we end.
So for like the very last child, in that weight statement, it'll actually just execute immediately and then just count.
So for this child right here, it actually will never print because it already executed before we did that wait statement. See, so if we had this executed actually in that if not fork. So it never hit that printf statement, never hit waits. Yeah.
Child processes actually duplicate separate copies of global variables.
Yes, yes. So when we're kind of looking at what a child process does, when you do fork a child, you take it, you take all of that chunk of memory, so all of the code, all of the stack, all of everything, and you put that into another section of memory. So it inherits any values of local variables, any values of global variables. It inherits that. That's why we know that this sig child inherits this parent, because it inherited that from its parent, who inherited it from its parent. Yeah.
So count 1, 2, and incremented before that fork.
Yeah, so before this fork, count 1 or 2 has been incremented, then we would take that into account and increment it. So then for question C, for the parent process started in the main function, what are the values of count 1 and 2 variables at the end of the function? So we're looking at this value now, or that first variable. We see that it gets a sig child here from its kind of secondary child. So that's going to go up to handler 2 again. We've got this pairing of handler 1 and 2. So count 2 gets incremented by 1. It also receives another sig child from this first child when it exits. That pairing, so for this parent, when it receives that sig child, it's got handler, it's paired with handler 2, so handler 2 gets incremented again. We know that it happens in that order because we have have that wait statement on this, child process.
Is that one that will receive the sick child after the exit of their office, or?
So, this child right here, the original child, so that receives a sick child when this guy exits, when it's child exits. Yeah.
So even though, that sick child was originally for handler, it was killed when the name's sick child was pregnant handler too, and that's like.
Exactly, yeah, so that's a very important distinction. So this child got killed off after its parent, who it's sending that sick child to, got paired with handler two. That's why we increment count two instead of count one. If that had happened before this pairing, then, we'd increment count one instead. Yeah.
So when you print at the very end, is it gonna be like the first one or one and the second one?
So the parent process will print count one of 0 and count two of 2. But the other, so remember this child process will also do the print, go through the print Fs. And that, again, we said we'll print count one is 1 and count two is 0. Yeah.
Oh, so then the furthest right one will send the signal to its parent, but not to the main parent.
Yeah, exactly. A child process only sends its sick child signal to its direct parent, not anywhere else. Yeah. How do we get two different PIDs? Right, so that is, the return value of fork. So if we look, that's actually not the PID of these functions. That got set